Assalamualaikum. Hi guys. We are going to start with the next chapter, chapter 5, states of matter. This is the first subtopic that we are going to focus, 5.1, gas, where you have to explain quantitatively the basic assumptions of kinetic molecular theory of gases for an ideal gas. Next one, you have to define the gas laws. There are 3 of them. And you have to know how to interpret the graphs of all gas laws, including with sketching of the graph. Next one, we are going to learn how to determine the molar mass of a volatile liquid by using ideal gas equation. You need to know how to define the Dalton's law, perform calculations using Dalton's law, and you need to know how to explain qualitatively the ideal and non-ideal behaviors of gases. And also, you need to know how to explain the conditions at which real gases approach the ideal behavior. We are going to start with kinetic molecular theory, where I'm going to explain a bit about the basic that you've learned during SPM level, where you know matter can exist as gases, liquids, or solids. So this is the process that we've known as conversion of states of matter. For example, if I want to convert from solid to gas, we need to undergo sublimation processes. So these all are what you've already learned and you've already known during your past experience from SPM level. We are going to apply this part along this chapter. So I'm going to introduce about gas first. So the volume of gas is greatly influenced by changes in temperature and pressure. But you should know that the changes in the volume of a gas do not depend on the chemical composition of a gas. Because of this, gas laws such as Boyle's law, Charles' law, and Dalton's law of partial pressure can be used to explain the physical properties of all gases. We can understand about the physical properties for specific gases, not the chemical composition or chemical properties. Kinetic molecular theory was invented by a scientist named Rudolf Clausius, where this theory can be used to explain the observed behavior of ideal gases. So what is ideal gases? Ideal gas is gas that obey the ideal gas equation. Very simple. And the equation is PV equals to nRT. So in this model, we should know that submicroscopic particles such as atoms or molecules that make up the gas are continually moving around in random motion, just like this one. And the movement is constant. Dan dia bukan sahaja berlanggar antara satu sama lain, tapi dia juga collide with the walls of the container because they are in gas phase. So this motion or this movement results in physical properties of gas such as heat and pressure. Kita boleh nampak ada perbezaan dari segi haba dan juga tekanan. So, we are going to discuss more about this movement where there are 4 basic assumptions of kinetic molecular theory. The first one is a gas consists of tiny particles of negligible volume. The second one, we should understand that the intermolecular forces of attraction do not exist between gas particles. Next, the collisions between gaseous particles are perfectly elastic. And the last one, the average kinetic energy of a gas molecule is directly proportional to the absolute temperature. So, keempat-empat basic assumption ni, we will discuss them one by one. The first one, we should know that gases consist of tiny particles that we cannot see by our own naked eyes. So maknanya dia separated from one another at great distance, tapi kita tak nampak secara jelas. As a result, there are a lot of empty spaces between gas particle. Awak boleh nampak ada ruang ataupun ada space between the particles. And since the size of gas particle is very tiny compared to distance that separate them and the volume of container, so maknanya volume gas tu kita tidak akan consider dalam faktor ini. Sebab tu, the volume of gas is negligible. For the next assumption, gas particle are moving rapidly in random motion, macam awak boleh nampak based on this diagram, and they travel in straight line and is not influenced by other gases. So, we can assume that there is no intermolecular forces between particles sebab dia move straight line sahaja. Next one, the third assumption, gases consist of tiny particles of matter di mana dia moving in a constant motion, and gas particles are colliding with each other and the walls of the container. Maknanya gas movement ni dia sentiasa bergerak dan langgar dinding container dan juga other gas particles. Dan pelanggaran ini antara dinding container dan juga other gas particle tidak menghilangkan tenaga. Maknanya there is no energy loss. Kenapa? Sebab energy is redistributed dalam partikel sahaja. So the increasing force of collision or the frequency of collision between molecules and the walls boleh menyebabkan pressure of the gas increases. Next one, the fourth assumption. Di sini kita akan relate dengan average kinetic energy of gas particle di mana it is dependent on the temperature of a gas. Sekiranya temperature tu bertambah, maknanya gas particle akan bergerak dengan pantas. So when the gas particles move very fast, therefore the average kinetic energy also increase sebab kinetic energy tu adalah energy yang support the movement of gas particle. So di sini kita ada properties of a gas di mana ini semua adalah physical properties of gas. For the shape, gas do not have a definite shape sebab dia akan ambil shape of the container. Kalau contoh gas dalam container yang bulat, so itulah shape for the gas. Kalau container tu dalam bentuk silinder, itu adalah shape of that gas. And then a gas do not have a definite volume. Maknanya volume untuk gas tu equal to the volume of container. Next one, compressibility. Gas is highly compressed. Maknanya kita boleh berikan tekanan kepada gas. Next one, density untuk gas is lower than liquids and solid. And the flow of gas particle are more free and move randomly in a straight line. Ingat, dalam straight line. And the diffusion of two or more gases very quick and easy with one another so that dia boleh form homogeneous mixture. So, mari kita sambung bahagian apa variables that describe a gas. So, kita akan observe based on 4 parameters. The first one, quantity. The second one, volume, temperature and pressure. So, let's go with the first concept of pressure, di mana pressure describes the force distribution at interface between two objects, maknanya force per unit area. Contoh kita ada between a gas and a piston. So maknanya kalau kita letakkan piston, awak akan ada tekanan dan pressure ini dia akan terhasil apabila gas particles collide with the walls of container and with other gas particle. Inilah yang dimaksudkan dengan pressure of gas, di mana force yang kita exerted on surface area yang menyebabkan pelanggaran antara gas molecules with one another dan juga dinding container. We have a specific device used to measure the pressure of the gas called barometer. And this is the SI unit for pressure. You should know that the most standard is 1 atm dan kita akan gunakan this one as reference unit. Then 1 atm also equals to 101325 Pascal or equals to 101325 Newton per meter square. Dan dalam kes ini we should understand that 1 Pascal equals to 1 Newton per meter square. The next one, 1 atm juga bersamaan dengan 760 mm mercury and also 760 torr. Dan kita boleh relate 1 mmHg bersamaan dengan 1 torr. So unit ni semuanya ada akan diberikan dalam exam, di mana dia akan berada di first second page for the list of constant. Awak boleh refer units kat situ. But what you should understand that this is the most common one that we use as a standard unit. So for this video, I hope you can understand that apa itu kinetic molecular theory, and you should know how to describe the properties of gas, and also the 4 basic assumptions of kinetic molecular theory. From there, you can continue to describe the variables of a gas. So saya harap awak juga faham tentang konsep of pressure, di mana awak perlu tahu the certain SI units for pressure. Hanya itu saja for this video. We are going to continue in the next one. Thanks for watching. Bye.